Yo, what up, fam? It's your boy, Big Walt, back in here with another episode of Block Boys University. Today, we're going to deploy a smart contract to the Goerli testnet. And though I'm a shortest path type dude, shouts to Dijkstra, we'll leave no stone unturned to make sure that you get all the information that you need. So rock with me. First things first, family. All source code for this video is available on GitHub. Just hit up the Hardhat demo repository in the Block Boys GitHub organization. The link is in the description. Before diving into the coding exercise, let me quickly put you up on Goerli testnet. When we deploy smart contracts to Ethereum for the world to use, we're actually deploying to Ethereum main network called mainnet. However, before we do that, we want to test our smart contracts to make sure that they work without the risk of wasting and losing real money. For this reason, a number of different Ethereum test networks or testnets have been spun up. Goerli is just one of them. There's also Sepolian, Rinkeby, and a few others. At the time of this video, Goerli is transitioning from proof of authority consensus to proof of stake in order to support the forthcoming Ethereum 2.0 merger. We are using Goerli because as of right now, it's best positioned for real-world Ethereum 2.0 smart contract testing. In order to deploy our smart contract to Goerli, we have to first modify our Hardhat configuration. We have to configure a target network for Goerli that includes an endpoint with an API key and the private key of a wallet that has access to the Goerli test network. We need a wallet because we have to pay for gas and things like that. I recommend using a secrets file to store your secrets and then reference that file from your Hardhat configuration. We don't want to risk getting our API keys and other secrets into source control. So basically, the secrets file is an easy way to do that. Obviously, when you go to production and things like that, you want to use environment variables or other mechanisms, but I'm not going to get into that right now. So what I want to do right now is show you how to get an API key from Alchemy. And if we go to Alchemy, you'll see right here that I'm in the Alchemy dashboard. You can create a free account with Alchemy, and you can, well, let me back up for a second. We're not running our own Ethereum node, so we really don't have a way to access the Ethereum mainnet or any of the testnets because we're not running a testnet Ethereum node. So for that reason, you have to use somebody else's node, an Alchemy or an Infura or whatnot. In this particular case, I chose to use Alchemy, and we're going to use Alchemy to get access via their APIs to the Goerli test network because they run Goerli test network nodes. Anyhow, you can see right here that I'm in the Alchemy dashboard, and they allow you to create a free account, and you can use service up to a certain point. For our purposes, the free account works just fine. And you will see when you create your account, they automatically create a demo app for you. And that demo app is on the Goerli test network. You can see that right here. I created an app called Hardhat Demo App, and that is on the Goerli test network because that's how I configured it. You'll see that it automatically comes with API keys here for your app. I'm not going to show you my app, but I will show you the what that looks like in the demo app. So I can just click View Key right here. And you can see that there's an API key for the demo app. And you also see that there's this HTTPS endpoint that has your the endpoint to Alchemy's API to get to their node, as well as the key associated with that. So basically, all you have to do is copy that HTTPS endpoint with the API key embedded into it. And that's what I would then put into my secrets file. And you can structure that secrets file however you want. I structured mine in a particular way, but there's a million different ways to skin that cat. Additionally, you'll need to get a private key from your wallet. And the reason why you need to do this is because you have to deploy the smart contract as an account. And so we need an account to deploy from. That account has to have some ETH because you have to pay gas fees and the like. And so for development, I use MetaMask. It's relatively easy. You can see here, I've got this account with this address that I've labeled dev1, and it has 0.5 Goerli ETH in it already. And so what I'm going to do is get the private key of this account. And you do that by clicking on account details, and you can then click this button to export the private key. I'm not going to do that. I'm just showing you how to do it. Once you get the private key, then you would then store that in your secrets file that you reference from the configuration. When you create a boilerplate Hardhat project, you get a default configuration file, and that default configuration file looks like this. And it's relatively simple. A lot of that's baked into this Hardhat toolbox import package. What we're going to do is add configuration. I've already cooked up a configuration. When you add the configuration, it looks like this. So you would create a networks object, and inside that networks object, you add objects for each network you want to configure. In this case, I only want to configure the Goerli network right now. And so in order to configure this object, I need a URL, and I need whatever accounts I'm going to be using for the deployment. In this case, I'm only going to be using one account. And I reference the private key from my secrets file that I use to deploy it. And my endpoint is also in my secrets file. And I got that from Alchemy, which I showed you how to do that. So this is pretty simple. This is all you need to do to modify your configuration to be able to deploy to the Goerli test network. All right, before we get into the deployment aspect of things, let's take a look at what it is exactly we're going to be deploying. And so inside the GitHub repository, you'll see that there is this hello smart contract. Basically, this is not really a glorified and underwhelming hello world smart contract that has some state and some behavior. From a state perspective, there are two pieces of state. There is a greeter, that's a string, which is basically meant to be the name of the person that's saying hello world or whatever. And then there's an identity counter. Those are the states. There's going to be a count. This is private, obviously. It's exposed through this greeter count. You can determine the number of times the greeter has changed through this. Then from a behavior perspective, there's the greeting, where it basically will give you, it'll spit out this hello world message, customized based on the state. Then we have the behavior that allows us to change the greeter. And then we have the ability to reset back to the defaults. And it's, like I said, super simple. So this is the thing that we actually want to deploy. Now, there are approaches to do this manually, everything from copy paste to doing it from a console. What we're going to do is write a script though. And so we're going to create a deployment script, and that's how we're going to go about the business of doing the deployment. So right now, I'm just going to create a new file in the scripts folder and call this deploy.ts. And this is our deployment script. And so the very first thing we want to do is get access to ethers.js so we can actually do stuff. And then we want to define basically a main function that does deployment for us. So this is not going to take any parameters. It's basically going to be a simple function. And apologies for the crying baby in the background. Anyway, the first thing we want to do is get a reference to a factory. So we'll call this guy capital hello, and obviously we want to do everything asynchronously. So we want to get contract factory. Yep. And the contract is called hello. We just showed you that. And then we actually want to deploy that. So we'll get a reference to that deployment. And we'll call the deploy function from the factory to do that. And let me clean up my white space here a little bit because I'm particular like that. And then basically we wait for the deployed event to fire. So this guy, right? And that basically will give us the deployment. And just to give us some warm fuzzies, let's log some information. Let's just say hello, contract deployed, if I could spell, deployed to address. And this is going to output the address of the newly deployed hello contract that we deployed. So that's kind of it from a script perspective. All we have to do from this point is basically just call the main method. And we'll do this in much the same way. You'll call any sort of method with a promise, trap the errors, and that sort of thing. So anyway, that's kind of that, fam. That is the most basic deployment contract you can have, I believe. So from there, all that's left to do is run it. Now that we've written our deploy script, deploying the contract is relatively easy as a simple command. Quick thing, typically we would be using npx. Can't type. Typically we'd be using commands like npx hardhat to execute our hardhat commands, but I've installed the hardhat shorthand package. So I'll just be using HH. It's simple. I just didn't want to confuse anybody who was expecting the nph hardhat command syntax. Anyway, hardhat run scripts deploy ts, and we tell it that the network is Goerli. And if you recall, we have configured in our hardhat config, we've configured the Goerli network. So when we use this network switch on the run command, that tells us which environment against which to run the script. So anyhow, let's go ahead and run it. And it should take a second, but according to the script, it should spit out a contract address once the contract is successfully deployed. And there it is. It says hello contract deployed to 0x44B5D3 blah 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 blah. So that's what's up. We are in fact deployed. So we can use the Hardhat console to interact with our deployed contract. Although there are other mechanisms we could use, we're going to use the console because that's relatively simple. So let's go ahead and kick the tires a little bit. Let me open up actually another terminal. All right, so I can start the Hardhat console and tell it that we want to use the Goerli network. And again, I'll refer you back to the configuration. Anytime we use that network switch, we have to name a network that was defined in the configuration. And in our case, it's this Goerli network. So it's going to use this configuration information to connect us to the network. So anyhow, the console will go ahead and launch. And once it has launched, we can do a few things. First thing that we'll want to do is go ahead and get a reference to our deployed smart contract. So much like we did in the script, we want to get a factory. So we'll use ethers to do that. Sorry. IntelliSense is not that great here, but the name of the contract is hello. So that will get us the factory. And then we will attach ourselves to the deployed contract. It's already deployed. So in this case, we'll use the factory and the attach method. And we'll swap back over here and get the deployed contract address that we printed out before. Go back to the console and plug that in. And oops. Forgot the initial quote. So let me remedy that. And this should give us the a reference to the contract. One of the things that we can do is check out the owner property. But let's do one thing first here. Let's first in this environment. Well, no, let's go ahead and do that. Let's say, no, let's do it the way I was talking about doing it in the first place. We know that we attached the console to the Goerli network. And so if we go ahead and get the accounts in the environment, let's just say let accounts equals await ethers.get signers. Right, do that. And then we will let owner equal the first one. And we've got that. So if I just do owner address, it's this EEF E7641CB, blah, blah, blah. So if I swap over to if I swap over here and open up MetaMask, you see that the ID or the account address is EEF E7641CB, blah blah blah, and that is the same. I'll just copy this here just so that we can see it exactly as it is. That is the same as this address, right? So that's one way to confirm that we are in fact in the right environment. And you'll recall that in the config file, we configured the private key of the account matching this address in this network configuration. So that all is working out the way it's supposed to. Now, one of the things we want to do is we'll want to find out who the owner is of this hello contract. And in fact, it is that exact same address, so that we know, we're kind of on the right track. We're getting feedback that we expected to get. It was from this address that we deployed the hello contract. The hello contract is in fact the owner. I'm sorry, this address is in fact the owner of the hello contract. So that's all legit. And so we can continue to interact. with our hello contract in this way. So we know we have a greeter that's public state. So if I get the greeter, it says Jane Doe. That is in fact the default greeter per this contract. If I tell the hello contract to greet me, or give me the greeting rather, then it says hello world, my name is Jane Doe. The greeter has changed 0 times. We can actually modify that by calling the change greeter function, and let's say we want to change it to John Doe, and that actually change the state so that you see we have the output from the transaction. So now if we run it back to say greeter, then it says Jane Doe. So something went wrong. The state didn't change. Something is not going on. Let me double check something else. If I could type await hello greeting. That's interesting. So the greeting is correct. As hello world, my name is John Doe, and the greeter has changed 1 time. That is correct. But the greeter string doesn't appear to have changed. Let me try this again. Wait, hello dot greeter. Oh, there, it has changed. That's interesting. I'm not sure why that happened. It may have something to do with the fact that I ended up going through the command history and called it, or it could be that the function just hadn't completed yet. So anyway, that's interesting. I wasn't expecting that, but that took us through that. So we've changed our state. It's not the default anymore. Another thing that we can do here, and this really isn't germane to, the educational purpose of this video. We're just kind of like dinking around with the contract. But if we call the reset function, hello.reset, I believe it's called, and do that, then call hello greeting again, then it goes back to hello world, my name is Jane Doe. The greeter has changed 0 times, which is the default state. So that's kind of that. We have deployed the contract, and everything is working as it should. So that's it. Now you know how to deploy and interact with your Ethereum smart contracts on the Goerli test network. Working hard, fam. Until next time.